Okay, so here's number 1. Let's ask ourselves, how many terms are there here? So in order to figure out how many terms there are, you really have to look at how many plus or minus symbols there are. So for example, if you have 2 minus symbols here, you know that you're separating 3 different terms. It's also important to note that these negative symbols are a part of the term. So if you look at this particular example, we would say that x squared, negative 7x, and negative 18, those are your 3 terms. So this is what we would call a quadratic trinomial. It's quadratic because the highest power of the x is 2, and it's a trinomial because of the 3 terms that we outlined before. Typically when we're working with quadratic trinomials, we are often referring to a, b, and c terms. The a term is simply whatever is in front of your x squared. If there's nothing written there, we just assume that a equals 1. The b term is whatever number is in front of your x, and in this case that would be negative 7. The c term is the constant that's at the end, and in this case it will be negative 18. So when we're doing trinomial factoring, the first thing we want to do is factor the c term. In this case, the factors of negative 18 could be 1 and 18, 2 times 9, so that would be 2 and 9, 3 times 6 would give you 18, so 3 and 6, and 4 and nothing, 5 and nothing, 6 and then 3. Once you get a crisscross like this, you know that you're done factoring. So these are our factor pairs, and our goal is to then pick 2 factors which could add up to our b term, negative 7. So we want to pay close attention to the fact that this is a negative 18. Well, if you think about it, it could be 18 minus 1 or 1 minus 18, 9 minus 2 or 2 minus 9, 3 minus 6 or 6 minus 3. We can do it any of those ways. And if you were paying close attention, you would notice that 2 minus 9, that would actually add up to negative 7. And so those are the factors that we want. Now that we've identified them, all we have to do is factor this into x plus 2, right? We put x with our positive factor and x with our negative factor, x minus 9. So that is how you do trinomial factoring, and we would say that we're done with this problem. Okay, so here's number 2. We're going to see that we have 3 terms here, and we're also going to notice that, like the previous question, the a term is equal to 1. So there is no GCF. We're going to go straight into trying to do trinomial factoring again. So let's take this c term, negative 14. Let's try to factor that. 14 would be like 1 times 14, 2 times 7, and that would pretty much be it. Those are our only options. So now we want to look at each factor pair and think about which factor will be negative so that they will add up to negative 5. Looking at 2 and 7, we would say, hey, those are apart by 5. Those have a difference of 5. So we should be able to either do 2 minus 7 or 7 minus 2. Of course, if we want a negative 5, we're going to make the larger number, in this case 7, the negative factor. And there you go. 2 minus 7 would give you negative 5. You're done. And you can write your 2 binomials, p plus 2, right? That's your positive factor, and p minus 7. And that's another example of trinomial factoring. Okay, here's number 3. This is looking just like the previous 2, so let's go ahead and try to factor 8. The factors of 8 would be 1 and 8, 2 and 4. Now in this case, our c term was positive. This is going to mean that either both of these factors are going to be positive, or both of these factors are going to be negative. This way they multiply to give you positive 8, and they could add up to different things. But we're trying to make them add up to a negative number. 1 and 8 add up to 9. If we want to make them add up to negative 9, we can simply make them both negative. Those are going to be your factors, and we'll write this as m minus 1, m minus 8. And you're done with that one. Okay, here's number 4. Again, we have 3 terms. We have a equal to 1. So we're going to try to do trinomial factoring. In this case, we have a positive number, 63. So we're going to go ahead and factor that. And 63 probably has a bunch of factors. Let's see, 1 and 63. 2 and nothing, because this is odd. To see if this is divisible by 3, we have a special trick. Just take the digits of the number and add them up. 6 plus 3 would give you 9. If this number is divisible by 3, then the original number will be divisible by 3. So yes, 63 is going to divide by 3. and 3 goes into 6 twice, 3 goes into 3 once. We could say 3 times 21. 4 would not work because 2 didn't work. 5 won't work because this doesn't end with a 5 or a 0. 6 is not going to be a factor because if 6 was a factor, you would also have 2, right? Because 6 breaks down into 2 and 3. So we will not be able to divide this by 6. 7 will work in this case. We know this is 7 times 9, and then 8 won't, but then you'll get 9 times 7. There's your crisscross. You're done factoring. And now let's go ahead and try to see which one of these can add up to negative 16. In this case, it looks like 9 and 7 would add up to positive 16, so we're just going to adjust those, right? Make that negative 7 and negative 9, and you're all set. You'll then write this as x minus 7 and x minus 9. Okay, so here's number 5. We have another trinomial, right? 3 terms. The numbers 7, 31, and 20 don't have any common factors because 7 and 31, these are both prime numbers, so they won't divide by anything. So we don't have a GCF. We also will not be able to do trinomial factoring because our a term is not equal to 1. When that's the case, when a is not equal to 1, you're going to use the next method of factoring that we want to cover today, which is called split the middle. Some people call this AC factoring, but you're basically going to take the a term and multiply it by the c term. 7 times negative 20 would give you negative 140. And what we're going to try to do is find all the factors of negative 140 that we can. There is a little trick that you can use if you have a graphing calculator and you're trying to factor a larger number like 140. You'll go to the y equals menu, you'll type in this number you're trying to factor, 140, and you're going to divide that by the variable x. And then if you hit second graph, you'll pull up the table. We've got 1 and 140, of course. We've got 2 and 70. We have 3 in a decimal, so we're not going to use that one. We have 4 and 35. We have 5 and 28. And we have 7 and 20. And let's scroll down to see if we have any more. We have 10 and 14. And some decimals, and then 14 and 10. That would be a crisscross, and so these are going to be our choices. So we want to pay close attention to the fact that 140 is a negative, which means we're looking for 2 numbers that are 31 units apart, right? That have a difference of 31, since one of these factors is inevitably going to be a negative. So let's see, 140 and 1, those are apart by 139. That's too far, right? 2 and 70, they're apart by 58, and we keep working our way down. Let's see, 4 and 35, those are apart by exactly 31, right? So we could either do 4 minus 35, or we could do 35 minus 4, and of course, we're going to want to make the bigger number negative. That way, they add up to negative 31. So here's where we have to split the middle. The middle term is negative 31x, and we're going to split that into 2 terms, and the terms are going to be built by these factors, 4 and negative 35. So we'll simply bring down the first term, 7x squared, and we can write either one of these numbers with an x first. So we could say plus 4x minus 35x. Again, the order you write those terms does not matter, and you'll bring down your c term. So now we've got 4 terms, and we're going to do something called factor by grouping. We're going to basically pretend that this is 2 separate expressions. So let's look at these first 2 terms, 7x squared plus 4x. The numbers 7 and 4 do not have common factors, but they do both contain an x. When 2 or more terms contain the same letter, we just take the lower power one, right? This would be x to the first, or just regular x. So our GCF would be x, and if we divide that out, 7x squared divided by x would just be 7x. 4x divided by x would just be plus 4. You always want to double check, make sure that x times 7x gives you what you had up here, 7x squared, and that x times 4 gives you what you had up here, 4x. We're basically undoing the distributive property. Let's look at the next 2 terms, negative 35x and negative 20. These numbers are both divisible by 5, so we could take out a 5 or we could take out a negative 5, but we want to make this decision based on what we got over here. Our goal is to get the same exact thing right here. And if you take out a negative 5 in this case, you'll be able to get the positive 7x plus 4. And if those both match, we can go to our next step, which is to actually factor these into binomials. What we'll do is we'll take the stuff that was on the outside here, the x and the negative 5, so we'll get one factor, x minus 5, and we'll get this matching stuff, 7x plus 4, as our other factor. And that is how you do split the middle. It's a couple extra steps, but once you practice this, it becomes a very quick process, almost just as easy as trinomial factoring. Okay, so here's our first example with two terms, and this would be considered a binomial. What we want to do is look for a GCF first. You'll notice that in all of the methods I put in the little box, you're always looking for the GCF first. So in this case, 7 and 9 do not have common factors, but both of these terms have a k. So we're going to factor out a k here and see what would be left over. 7k squared divided by k, that will leave us with just 7k. And 9k divided by k, the k's would cancel, you'd get positive 9. And just double check, right? That gets us back to 7k squared plus 9k. So we're all good there. And that's it. That's considered factored. So typically when you're factoring expressions, you will know that you're done once all of the variables are to the first power. That typically means you're not going to be able to factor things any further. So this is your answer for this problem, and it was just a simple GCF. Okay, here's number 7. So we have 7x squared, negative 45x, and negative 28. They do not have a numerical common factor, and they don't all have an x. So we don't have a GCF here, and we're not going to be able to get rid of this 7 in front of the x squared. So we have to then go to our next possible method, which is split the middle. We saw this once before today. We want to multiply the a times the c. 7 times negative 28 is negative 196. And let's go ahead and use our calculator to see what factors we have. So we want to go back to the y equals menu. We want to change this to 196. We want to go back to our table. Here we are. We've got some factors. 1, 196. 298, 3 in a decimal, we skip that, 4 and 49, 5 in a decimal, 6 in a decimal, we got 7, 28, and we've got 14 and 14. Those match, so that will be the end of your factoring list. So again, we have a negative number we're factoring. So if we look at our factors, are any of these apart by 45? And if we just run down this list, it looks like 4 and 49, those are apart by 45. Since we want a negative 45, let's make the bigger number negative. We're now going to split the middle term using these two factors. So let's bring down the 7x squared. Let's split the negative 45 into minus 49x and plus 4x. So you might be noticing here I didn't put these in the same order that I wrote them over in the factoring table, and that's okay. It doesn't actually matter the order you put them. The reason I put them this way is because I know that 7 and 49 have a common factor, and that'll be nice when we go and do GCF in just a minute. Let's bring down the negative 28. We can put a little artificial wall between these two terms if we want, and let's go ahead and try to find the GCF. So 7 and 49, they have a GCF of 7. X squared and x, they have a GCF of x. So we'll factor out a 7x. And it looks like we'll get left with x minus 7. So over here we have a 4x minus 28. We could either factor out a 4 or a negative 4. And in this case, a positive 4 will work because that'll leave us with x minus 7. And you see again, we've got some stuff on the outside. This is one factor, 7x plus 4. And then these matching binomials, x minus 7, that will be our other factor. That's it. That's another example of splitting the middle. All right, here's number 8. Let's start moving a little quicker. This is another split the middle, right? We've got 3 terms and nothing is going to be factoring out. So we're going to go ahead and do a times c. 2 times 21 is 42. And this is not too big. We should be able to factor this one in our heads. 1 times 42, 2 times 21, 3 times 14, 4 times nothing since 2 is with an odd number, 5 nothing, 6 and 7. The next one will be 7 and 6, so we're done factoring. And so this is a positive 42. We want to see which ones can add up to a positive 17. In this case, 13 and 14 will work, so we're going to go ahead and split the middle. 2b squared plus 14b plus 3b plus 21. We see we've split the 17b into 14b and 3b, and we're going to now do the GCF of the first two terms here, 2b squared and 14b. Looks like we could take out a 2 and a b. We would be left with b plus 7. Over here, 3b and 21, we can take out a 3. So we'll be left with b plus 7. There you have it again. We have 2b plus 3. That's one of our binomial factors. And b plus 7. That's our other binomial factor. That's it for number 8. Okay, here's number 9. We've got 5p squared minus p minus 18. Again, we'll notice 3 terms. We'll also notice they don't have any common factors. So let's try to split the middle. 5 times 18. That would be 50 plus 40, or 90. And let's go ahead and try to factor 90 without the calculator, right? 1 times 90, 2 times 45, 3 times 30. 4 we're not going to be able to do because, again, 2 is with an odd number as a factor, so you will not be able to divide by 2 again. 5 and 18. 6 should be able to work, right? If we double this 3, we'll cut this in half. So that's 6 and 15. 7 won't work. Then 8 also won't work since we don't have a 4. 9 should work, 9 and 10, and then of course you would have 10 and 9. That's the end of our factors. Oh, looks like I forgot to write my negative in front of my 90. Always double check that, right? Are we factoring a positive or a negative? Okay, so if we're factoring a negative number, that means we want to find numbers with a difference of -1 here. And let's see, are any of these apart by 1? Sure. 9 and 10 could have a difference of 1. Looks like we've got a -1, so let's make the larger of the two factors the negative. 9 minus 10 would equal -1. And we're ready to split the middle. So we've got 5p squared plus 9p minus 10p minus 18. And let's see, the first two terms, their common factor would be just p, and we'd be left with 5p plus 9. Over here, we could factor out, it looks like a 2, right, or a -2. These are positive and these are negative, so I probably want to factor out a -2. That way, the leftover stuff will become positive. So we'll get 5p plus 9, and there you go. You have your outside stuff, p minus 2. This is one factor. And your inside stuff, 5p plus 9. All right, so here's number 10. We have 3 terms, which means we want to start again with GCF. It looks like we will have a GCF for 28, 16, and 80. So for 28, you could divide this into 7 times 4, and 16 would be 4 times 4, and 80 would be 20 and 4. Is that the greatest common factor? Well, I think it would be, right? Because 7 and 4 and 20 then don't have a common factor. So your GCF here is going to be 4. But you also have n's in each one of these terms. So we're going to take the n with the lowest power, so n squared. So altogether, our GCF will be 4n squared. And let's see what would be left over. 28 divided by 4, that would be 7. N to the 4th divided by n squared, that would be n to the 2nd. So notice when I factor out, I'm just going to go through each term number by number, letter by letter. 16 divided by 4 would be positive 4. N to the 3rd divided by n squared would just be n. Negative 80, right? Make sure you're saying to yourself negative 80, right? It's not just 80. Each term is attached to the symbol in front of it. And now negative 80 n squared. Negative 80 divided by 4 would be negative 20, and n squared divided by n squared would cancel out, so you're left with this. So now let's look at this trinomial that we're left with, and it looks like we're going to have to use split the middle factoring. Let's go ahead and multiply a times c. 7 times -20, that'd be -140. And I believe we factored this earlier, so let me go grab the factor chart that we just had. Okay, so here's our factor chart for -140, and again, since this is negative, we want to choose factors who have a difference of, in this case, positive 4. So if you have a difference of positive 4, you're looking for factors that are very close, and you should look towards the bottom of your list, right? Far apart on the top, close on the bottom of the list. It looks like 10 and 14 would be our candidates, and we want this to add up to a positive 4, which means we actually want to do 14 minus the 10, right? We want the smaller number to be the negative one. 14 minus 10 gives us positive 4. So let's go ahead and split the middle, and just make sure we're careful in just bringing everything else down, right? We want to bring down the 4n squared, that was our GCF. 7n squared, that's our first term, and here we are, we're going to split the middle. We've got a negative 10n, and a plus 14n, and bring down the minus 20. We've now got 4 terms in the parentheses. Let's try to see what our GCF would be. Let's bring down 4n squared. These first two terms, 7n squared minus 10n, your GCF would just be n because 7 and 10 don't have any common factors. So we'll be left with n times 7n minus 10. And then over here, for 14n minus 20, we have a common factor of 2. So if we take out a positive 2, we would be left with 7n minus 10. And don't forget there's 2 layers of parentheses here. So our last step would be to rewrite everything here in the parentheses as 2 binomial factors. So the 4n squared keeps working its way down, and then we're going to get n plus 2 for one of the factors, and the stuff on the inside, 7n minus 10. And that's it. That is now completely factored. So earlier I did say that we know we're done factoring once each of our variables is down to the first power. Of course, there is an exception here if we're talking about a monomial that's out in front of your binomial factors, because that just simply can't be factored further. So when I said that, I really was referring to binomials or trinomial factors, not so much the monomial that might be in front. So this is indeed the end of the question, and that's how you would factor this one. All right, so here's number 11. It looks like we will have a GCF, right? Because all 3 of these terms have a b. The numbers 3, 5, and 2, they don't have a greatest common factor, so let's just go ahead and take out a b. So we'll be left with 3b squared minus 5b plus 2. And then this one, it looks like we have an a term of 3, so we're going to go ahead and try to split the middle. So let's go ahead and multiply 3 times 2, which would be 6, and your factors of 6 would be 1 and 6, 2 and 3. And since it's a positive 6, we want our numbers to add up to a 5, not have a difference of 5. So 2 and 3 are going to work. Since it's a negative 5 we want to add up to, make both 2 and 3 negative, and that'll work. We'll have negative 2 times negative 3, which is positive 6, and they'll still add up to negative 5. So now we're going to bring down the b. We're going to go ahead and split the middle, bring down 3b squared, and we're going to split our negative 5 into minus 3b minus 2b. Again, I'm putting this negative 3 first here because I like that 3 and 3, b squared and b, those will all have nice common factors. Then we're going to bring down the 2, and now let's take GCFs. So we're going to have 3b, that would be our GCF for the first 2 terms there. You're going to be left with b minus 1. Over here, negative 2b plus 2 will have a common factor of 2 or negative 2. If we were to take out a positive 2, we would end up with negative b plus 1, and this would be sort of the opposite of what we got in this set of parentheses. So if that's the case, if you factor out a number and you're getting the opposite of what you want, just take the opposite sign. So take out a negative 2 and it should correct itself. This is something that's going to happen when you're new at this, and your goal again is to always make sure this parentheses and this parentheses match up. The reason that you want those 2 things to match up is so you can do this last step. So I actually haven't really explained why they have to match, so let me do that now. If you think about it, I could rewrite this as b minus 1 times 3b minus 2. And if I put this outside stuff second, you're going to start to notice that, hey, instead of doing the sort of normal double distribute or FOIL method, we can actually just pretend this whole b minus 1 term is just distributing twice, right? And that would get you back to this previous step. So factor by grouping is really an undoing of the distributive property, and you're sort of undoing the distribution of a binomial, in this case b minus 1. So I have been writing the outside stuff first, 3b minus 2, and the inside stuff here second, but the order doesn't really matter. That's it for this problem. Let's take a look at the next one. Okay, here is number 12. It looks like we don't have a greatest common factor, and we're going to go ahead and try to split the middle. 7 times negative 60 is going to give us negative 420. That's going to have a lot of factors, so let's try to narrow this down and anticipate what factors we're looking for. We have a negative number, and we want to find factors that have a difference of 32. Let's pull out our calculator, and let's go to our y equals and put in 420. And let's hit second window. Let's make sure our table starts us off at 1. And let's go to our second graph. Let's go to the table. And now let's start looking for factors that have a difference of 32. So I'm not going to write them all down. I'm just going to go look for ones that have a difference of 32. 7 and 60 are still too far apart. 10 and 42 look like they could work, right? Because 42 minus 10 would be 32, and 10 minus 42 would be negative 32. So let's go ahead and write those two down, 10 and 42. It was a negative 32, so we want to make sure the larger of these two factors is the negative, and we found our numbers, 10 and negative 42. Let's split the middle. We're going to have 7x squared. Let's do plus 10x minus 42x minus 60. First two terms here, they both have an x, so we'll take out an x, and we'll be left with 7x plus 10. And we want to get left with the same thing, right? 7x plus 10. What would we have to factor out? Well, negative 42, if we factor out a negative 6, would give us a positive 7. So let's take out a negative 6 and just make sure it works, right? Negative 42x and negative 60, that works. And here's your answer, right? We've got x minus 6 as the outside factors and 7x plus 10 as the inside factors. That one wasn't so bad. We just had to make sure we look for the appropriate factors. All right, so this is number 13, and this is the first example we're seeing with two different variables in it. We're going to not freak out. We're going to approach this the same way we've approached other questions, right? There are three terms here. Let's see if there's a GCF. Clearly, all of these terms have a b, so we're going to be able to take out a b. Let's look at the numbers, 30, negative 87, and 30. So both of these 30s have factors of 3. Well, what about 87? Does that have a factor of 3? Remember, you can add the digits up, and if you get a two-digit number, you can add those digits up until you get what's called the digit sum. So if the digit sum is 6, and that's divisible by 3, then the original number, 87, is divisible by 3. So we're going to take out a 3b. And let's see what we're left over with. 30 divided by 3 is 10, and n squared b divided by b, the b's will cancel, and we'll just have n squared. Negative 87 divided by 3, I think that would be what? 3 goes into 8 twice, and then you'd have a remainder of 2, 7, so 3 goes into 27 9 times. That looks like we'll have a negative 29. And b divided by b would cancel, leaving you with negative 29n. And let's see here, 30b divided by 3b, that will just leave us with 10. The b's cancel out. Okay, so we've taken out 3b, and we have a trinomial. Can we factor that further? It looks like since there's a term that's not equal to 1, we're going to try to split the middle on this. So let's multiply 10 times 10, our a times c, and that would be 100. Are there factors of 100 that'll add up to 29? Again, we want to make them add up to 29 because 100 is a positive number. So either we're going to get positive, positive, or negative, negative. So we've got 1 and 100, 2 and 50, 3 and nothing, 4 and 25. And we could stop there because 4 plus 25 is 29. But again, pay attention to the fact that this is a negative 29. So we're going to want to make these both negative. That way they add up to negative 29. So 3b will be brought down. We have 10n squared being brought down. And we're going to split this middle in two. Let's see, minus 4n and minus 25n plus 10. And let's bring 3b down again. And let's see, what is our GCF for 10n squared minus 4n? Looks like we're going to be able to take out a common factor of 2n, which will leave us with 5n minus 2. Over here, if we want to get left with the same thing, 5n minus 2, we would have to take out a negative 5. And that should work out, right? Negative 5 times 5n, negative 25n, negative 5 times negative 2 is positive 10, so that's nice. And here we are at our answer, so we're going to have 3b times 2n minus 5 times 5n minus 2. And that's it for number 13. All right, here's number 14. It looks like we have three terms and no GCF here, so we're going to try to split the middle again. Let's see, 9 times negative 10, this will give us negative 90. Again, pick up on the fact that for negative numbers, we're looking for a difference, whereas before we had a positive number, we wanted those to add up. So let's see factors of 90 that have a difference of 5. Let's see, so 1 and 90, 2 and 45, 3 and 30, 4 and nothing, 5 and 18, 6 and let's see, we have 2 and 3 as factors, so if we double the 3, we'll cut the 30 in half, that's 6 and 15. And we're not quite off by 5 yet, so let's keep going. So 7 and nothing, 8 and nothing because we do not have 4 as a factor, 9 and 10 obviously. And so let's see, can any of these have a difference of 5? So with this particular example, we just don't have the factors, and in this case, we would just say this is not factorable. Number 15, we can see that we have an R in each term, so we definitely have a GCF. What about the numbers here? The number 70, only divisible by 7 and 10, also 2 and 35. But 73, I'm pretty sure, is a prime, so we're not going to be able to get any common number factors out of this one. So we take out the R, and we're going to be left with 9p squared plus 73p plus 70. And it looks like we're going to be left with a trinomial where we're going to have to split the middle, again, because a does not equal 1. So 9 times 70, this is going to give us 630. That is a huge number, so let's use the calculator to see what our factors are. Once again, you're going to go to the y equals menu here. You're going to type in your number, 630, and go to your second window, which is the table setting, and make sure you're starting at 1. Then hit second graph, and you're going to be over at the table. So we're looking again for numbers that will add up to 73. So let's take a look and see if we can find such numbers. And it looks like so far these are going to be too big. 7 and 90 adds up to 97. That's pretty close. Let's see what our next possibility is. 7 and 90. 9 and 70. So again, let's keep going here. 10 and 63. Oh, I think that would be it, right? 10 plus 63. That would give you 73. So those are going to be our factors. Let's write those down. 10, 63. And if we just keep those both positive, it'll multiply to positive 630. It'll add up to positive 73. So that's nice when it's all positive. So we're going to split the middle now. Bring down your R. Let's bring down 9p squared. Let's go plus 63p plus 10p plus 70. And let's go ahead and see what our greatest common factor is for the first two terms there. Again, this is called factor by grouping. We're going to be able to take out a 9p, and that'll leave us with p plus 7. And then over here, if we want to get left with p plus 7, it looks like we're going to factor out a 10. And a positive 10 should do it. And there you go. So our final answer is going to be r times 9p plus 10 times p plus 7. And that's number 15. So here's number 16, and we again have three terms here, and it looks like we're not going to be able to factor anything out. So we're going to go for split the middle. 9 times negative 56, that'd be like 9 times 50, which is 450, plus 9 times 6, which is 54, so that should give us negative 504. Again, we've got a big number here, so let's go to the calculator for this one. We have a negative 504, so that means we actually want to find factors that have a difference of 7. So let's put that in, 504. Again, second window to make sure we're starting at 1, and then second graph, and here we go. We're looking for factors that have a difference of 7. So I'm going to go down because the lower we go on these lists, the closer together the numbers are. 12 and 42, not quite close enough. 14, 36, same thing. Let's see, 8 and 28, those are apart by 10, so we're getting closer. Are there anything else? Then we go to 21, 24. Let's just put those numbers down in here, right? 18, 28, 21, and 24. We are not going to be able to get a difference of 7. And that means that this is not factorable. here's number 17, and we see that we have an x that we can take out. Our b term here, 43, that's a prime number, so it's not going to have any factors, and we're just going to be able to take out the x. So if we take out the x, we've got 4x squared plus 43x plus 30. And we're going to have to split the middle on that, so 4 times 30 is 120. And can we find factors of 120, which add up to 43? So let's go ahead and see if we can do that. So 1 and 120, 2 and 60, 3 and 40, and yes, those will work, right? 40 plus 3 would be 43, so we're ready to split the middle. We've got x times 4x squared plus 3x plus 40x plus 30. And let's go ahead and find the GCF of the first two terms there, 4x squared plus 3x. We're going to be able to take out an x, and we'll be left with a 4x plus 3. Over here, 40x plus 30, we should be able to take out a 10. And everything's positive here, so we'll take out a positive 10. We'll be left with the same thing, 4x plus 3. And we're here at the answer. We're going to bring down this x. And then let's see, we'll have x plus 10 and 4x plus 3. All right, here's number 18. We've got 10m squared plus 89m minus 9. It doesn't look like any of these are going to have common factors because 10 is only divisible by 5 and 2, which neither 89 nor 9 are going to be factorable by those numbers. So we're just going to go ahead and split the middle. 10 times negative 9 is negative 90, and we factored this number a couple times. Let's see if we can get factors which have a difference of 89. Well, actually, if we just start with our first ones, 1 times 90, those are off by 89, so we should be able to use those, but which one is negative? Again, if we have a positive number, we are going to subtract the lower number, right? Because 90 minus 1 would give you 89. And we're ready to split the middle. 10m squared minus m plus 90m, and bring down the minus 9. And we'll go ahead and factor out an m for our first two terms. We'll have 10m minus 1, and let's factor out a 9. We'll have 10m minus 1. This is going to be m plus 9 times 10m minus 1, and that's it for 18. All right, so for 19 and 20, we have some critical thinking questions. So it says, for what values of b is the expression factorable? And they're showing us the b in the b term positions. And so we've learned today that if there's nothing out in front of x squared, it's just a 1. And if the a term equals 1, we can just try to find factors of the c term, which is 12. So let's see what our choices would be. We would have 1 and 12, 2 and 6, and we would also have 3 and 4. So let's see, what b values could we make? So we've been discussing that if we're factoring a positive number, that the factors have to be both positive or both negative, which means we're going to get positive or negative sums. So for 1 and 12, we could either have positive 13 or negative 13. So our answers are going to be either the positive or negative sum of each factor pair. So 2 and 6 would make 8. That means we could get positive or negative 8. And 3 and 4 would add up to 7, so we could get positive or negative 7. And that's how we would answer number 19. So if b were any of these 6 values, we would consider this to be factorable. All right, so here's number 20. It says name 4 values of b which make the expression factorable. And in this case, b is in the c term position, so that's the number we're going to factor. So whatever number we're factoring, we want to make sure that the factors add up to negative 3. Right, so technically here, b could be a positive or negative number. Just because we have a plus here doesn't mean that b has to be positive, so we should be prepared for b to be either positive or negative. So let's see, what numbers could add up to negative 3? Well, there's actually an infinite number of possible numbers that add up to negative 3, which is probably why they're saying just name 4 values. So let's go ahead and try to figure out what 2 numbers could add up to negative 3. I'm going to go ahead and start with, let's see, negative 2 and negative 1. Those add up to negative 3. All right, let's think of some positive and negative numbers that might add up to negative 3. So for example, we might think of 1 minus 4. Those would add up to negative 3, or maybe 2 minus 5. And let's just get one more. So how about 3 minus 6? all of these factors would add up to -3. So what number or C term, or in this case B value, would you get if these were the two factors? So -2 and -1, if you multiplied those would give you +2. 1 and -4, if you multiply those, would give you -4. 2 times -5 would give you -10. And 3 times -6 would give you -18. So our possible B values here could be 2, -4, -10, and -18. You could probably come up with a lot of different answers for this question, but that's just how you'd want to think about it. You're kind of backwards engineering the question for number 20, and that's why it's a critical thinking question.